Hello and welcome to this MOOC on antennas course. My name is Fernando Las Heras and I am professor at the University of Abele, and I will be talking about reflector antennas and particularly on feed antennas, polarizers, orthogonal mode transducers, radomes, and typically elements that we find in any reflector antenna configuration. So first, feed antennas. We need antennas to be placed on the focus of a typical parabolic configuration. So we need some kind of not very big antennas. They are very close to resonant antennas. And it is the horn antenna, one of that best fit to these requirements, because also they have a medium gain, good matching, high frequency bandwidth, easy design and fabrication, and as said, moderate size to put them in the correct focus of the parabolic geometry. The typical use horn antennas are circular corrugated horns because of its symmetry in the radiation pattern, and even to minimize the depth of these horns, we use typical choke antennas. Other alternatives are rectangular horns, sectoral H and E plane, or pyramidal. And even for lower frequencies at UHF and L band, we find some reflector antennas that are fed by helix antennas. Another element typically that is typically found in feeding reflector configurations is the polarizer. Polarizer is used when need to transmit or receive in a circular polarization. In this case, it typically can be found close to the feed antenna. And there are different alternatives of design of this kind of polarizers. In the upper part, we can see a figure in which it is a dielectric plate which is placed at some inclination, 45 degrees, with respect to the incident field. So if the incident field is decomposed in two components, one perpendicular to the dielectric plate and the other in the same direction, with the appropriate permittivity properties of the dielectric and the appropriate length, we can finally get at the output the two components in which one of them is phased 90 degrees with respect to the other normal component. So by combining again these two components, we obtain at the output a circular polarization. Another example is the one of the bottom figure, in which a sectum is used for this polarizer design. Other element that can be found when feeding a reflector antenna is the orthogonal mode transducer, which allows the superposition at output port, both in rectangular or in circular waveguides, of two orthogonal linear polarizations coming from isolated input rectangular waveguides. Here you can observe in these figures in the upper part model of these OMTs. Both designs can be made for a rectangular or circular waveguides, and they are very useful when we decide to transmit or receive two linear polarizations to take a benefit of polarization diversity in communications. Some elements to take into account in this OMT design are the matching at the input ports, the isolation between input ports, and the output cross-polar components. Of course, frequency bandwidth to the desired communication application. And other elements that typically we see in some emplacements are the radomes. Radomes, planar or spherical radomes, are used in some reflector antennas typically placed in communication towers at high elevations, typically in the peak of mountains, and they are used to protect the reflector and feeding configuration from meteorological issues like rain, snow, ice, and even to maintain a certain temperature in the system. With this, we conclude this part of the reflector antenna regarding other elements as feed antennas, polarizers, and OMTs. Thank you very much.